So I'm Philipp. I work for Elastic, the company behind Elasticsearch and various other products. I was kind of looking forward to being in Bucharest with you today. As it happens, I'm on the road, so I'm doing this from a hotel room, and I'm hoping that my hotel Wi-Fi will actually survive this one. Otherwise, apologies already. So let's dive into the topic, state of OpenTelemetry. For those of you who have never heard of OpenTelemetry, you will find something in this talk. For those who are already using it, I hope you will still find some new bits and pieces. So let's dive into the topic. I'm a developer advocate, so I generally talk about like what is out there, like the good things that you can use, what you might want to skip for now, and where to get started. So let's dive into that. Before talking about OpenTelemetry itself and what it brings, I'm kind of just trying to draw this bigger picture of what is out there and what you can use. So logs, I assume, are used by pretty much everyone. It's basically a chronological record of events, and that's often your first tool you're trying to use when something goes wrong. And then you have maybe a tool like the classic elk stack, Elasticsearch log session Kibana to give you those, which might nowadays look something like this. And it could be something like your Java logs, it could be something like your Nginx logs that you see here, and you might just look at them, try to find errors, what went wrong, what happened in general, just to figure out how things are going. And logs are kind of like easy to get started because, here I should add this information. So it's very straightforward. It's also very much a manual process because any log message that you have not added is not there. And then you will need to potentially redeploy your code with additional log messages to figure something out. So it can sometimes be painful. It's still kind of the go-to tool that many of us are using. However, sometimes if you have a lot of logs, it's very hard to figure out what is even going on overall in my system. And what you then want to have is potentially you want to go from logs to more structured events when you have more context around it. So for example, my classic example is you having a login service, and I don't know, you're using Spring Security or whatever you're using. And you don't just want to have like the log message that says like somebody failed to log in, but you probably want to have a more structured way to look at that data. So rather than just having that log message, you might want to have something like which user was affected, where was the request coming from, what was the endpoint, what was the state of the event? Because with all of these, once I have those, I could then easily make a graph out of those and see like what is the success versus error rate of my logs, which if I have 1,000 of these, I will not be very good normally at parsing that out in my head and figuring out what is the current ratio. So the more structure you add to your logs, the more useful they will be. Taking this concept like kind of like one step further is, or to the other extreme, is just using metrics, where you just count like how fast is something succeeding or failing. It doesn't really allow you to figure out why something is failing, but it gives you a very good overview, very fast overview of how things are. And metrics are generally periodic measurements of some numeric key performance indicator. So they know what is the response time of your site, what is the ratio of 400s, 500s, and 200s, what might be, maybe you track like the number of people who were able to log in or fail to log in, and you might have a dashboard or alert if you have more than 10% login failures. All of these are very good with metrics because they give you a quick overview. The kind of downside or problem of metrics is that they don't tell you why. You only see something is failing, but you have no real idea why. Prometheus is potentially or probably the most widely used tool for that. There are various ways to visualize those then. Whatever numeric measurement you have, it could be system metrics, it could be application metrics, it could be some business aspect of your application. All of those might tell you something that is interesting if you're running out of resources, if your system is being flooded by good requests or bad requests, if you have some error in a payment provider. All of these you could capture easily with metrics. Another thing that you often want to have is uptime, like pinging a service to see if it's up or down rather than waiting on users to complain, might be ping them or whatever. And then it could look something like this, where you just see like this is the number of failed requests and this is the number of successful requests to get an overview of these. And last but not least, traces, I always feel like traces are kind of like trying to extract some of the value of both metrics and logs so that you have more measurement automatically extracted, plus a deeper background information of why something is happening. So it's really the context of a request. So rather than looking at, oh, we have individual log lines, or we have this dashboard which shows the aggregation of all the data, it shows really the context of one specific request. The downside of traces is mostly that it's kind of a heavy tool because it collects a lot of information. It needs more processing and more storage, but that heavier tool also opens new possibilities. And the classic tools I want to say for tracing were Zipkin and Jaeger, which basically paved the way. Also, Jaeger normally has a white background here, but I think the pinkish background makes it look very very intense as well. Anyway, so what tracing might give you is something like, oh, this is the latency of your request, and you then get what is the latency of these requests, what is the throughput, where are you spending your time, what is your failure rate, all these things could automatically be extracted from traces. And especially if you're in the Java world, the nice thing about tracing is that it can auto-instrument your application, or in general, tracing will do a lot of magic for frameworks that it understands well. So especially if you're using something that is as widely used as Spring Boot, the auto-instrumentation is very good. So it will automatically know that this was a database request, and this is the how long the database request took, and this was the response of the database request. And so you know, where did you spend your time, what worked, what didn't work. If you use some more obscure frameworks like, I don't know, Javelin or whatever else, the chances might be better or worse that some tracing tool supports them or not. But we'll get a bit more into that later. But the good thing is the feature of tracing is really that it's really more looking at the request scope, and not so much like, oh, there are random log lines and I don't know how they even belong together and what happened here. But it's really looking at one request and like, how long did the request take? Where did it fail? Did it succeed? Where did it spend its time? The kind of like old name for tracing was sometimes application performance monitoring, or APM. The newer term is distributed tracing, depending on who you talk to. Some people are very particular about like, these are two different things. And I'm more on the side like, well, for the monolith, you started with APM and then kind of like the world evolved and everybody is doing distributed systems, or to some degree a distributed architecture. So the tooling had to evolve as well. And for me, APM is just like has morphed into distributed tracing. Some people are very specific about like, no, some tools belong in this group and others in that group. And I'm not sure if that is very helpful, because pretty much everybody has kind of like moved on in their tooling from the monolith to support something more distributed by now. And what Wikipedia tells you about what APM is doing is the monitoring and management of performance and availability of software applications. And why did that kind of like change, and why did that become more important as well, is to a large degree this. So this is a very crude example, but let's say in the past you had simpler times where your user was requesting something. Maybe they were going through a load balancer and you had your monolith, and your monolith talked to exactly one database, got responses back, and then the response got back to the user. And that was simple. And that worked with logs and metrics, and everything was pretty much good. And nowadays, your architecture probably looks something like this, or maybe even worse. So a request comes in, it works its way between various services, various databases. You don't even know if something fails, where did it fail? If something is slow, why was it slow? That's why you suddenly need much more of this tooling, why logs and metrics are potentially not enough anymore, and why APM had to evolve. And then we reach this point of distributed tracing, or nowadays more on the OpenTelemetry side, which says like, okay, we have these complex architectures, we need better tooling to support those and let us figure out what is breaking, what is making our users unhappy, what is failing, and how can we fix that. That is kind of like the big push of why do we need better tooling, and why is OpenTelemetry A, being so successful, and B, being pushed so widely. And I think the way we build our applications nowadays, pushing or having simpler individual services, but pushing that complexity on that integration layer and then having or needing more tooling to monitor that integration layer. That is a large degree of why we need OpenTelemetry and more of that tooling. So what is OpenTelemetry doing, or what are you generally doing with distributed tracing? You have transactions and you want their context. So maybe you have some meta information, like if you have a shopping cart, you might want to see like, oh, this is like what the value was, or this was the payment provider that you had in that transaction, and all of these things that could be helpful. You also want to be able to reconstruct the flow. So basically, your request hit this service and that other service, and then kind of like it combined the response and send it back. But you want to be able to figure out like, how did the information flow? And where did you spend your time? What was slow? What failed? That is important to reconstruct that flow. And of course, you want to query and visualize these transactions that you have collected to see like, what is my 99% percentile latency? What is the average error rate that I have over all my services? What is the error rate for this specific service? All of those you want to query and visualize to proactively look at what is going on. But B, also if something horribly fails and your boss is standing behind you and shouts, that you can pull up some tool to actually figure out like, okay, what is going on? What do I need to fix now? In terms of technology and terminology, and that is pretty widely used by now, is we have a so-called trace. That's a record of a request, and it's a directed acyclic graph. So basically the request comes in, and then it might kind of like break out into multiple services, and then it might kind of like be combined again to have the response that gets back to the original user. A span is a named and timed single operation that could optionally be nested. You might think of it maybe like a method call to some degree, that within that trace, you have multiple subspans that make up that entire trace. You have a so-called span context, which IDs a request, and then you have context propagation, which basically attaches that ID and keeps it along as a request works its way throughout the system. So the request comes in. The first service normally generates a unique ID, and that request, as it kind of like works its way to various other services, keeps that ID. And then you can reconstruct everything by generating the unique ID at the beginning and then always keeping it along the request. If you use HTTP, for example, it would be an HTTP header where you normally keep that along. That is how you can then reconstruct the entire request afterwards. Even if it touched systems on 20 different machines and databases, as long as you have the ID, you can always reconstruct it afterwards. The problem with these IDs was for a long time, and that is one of the things that kind of like pushed OpenTelemetry, was that lots of vendors have their own tooling for that and all had their own IDing system, which basically means that once you start using one vendor, you have to use that vendor everywhere and you cannot bring in any other vendors because their IDs look totally different and you could not correlate those IDs anymore. Why is that potentially a problem? Because maybe some vendors support some backend services better than frontend, or maybe they don't have something that allows you to trace your client applications or mobile applications, and then you're kind of stuck. So you always had kind of like to buy fully into one specific vendor. And that wasn't so great. Then people were like, well, maybe these IDs at least should be kind of like translatable between systems so we can hand them over from one to the other. And that was what created OpenTracing, which is deprecated now or pretty much dead. The kind of like main downside is it starts with ONT, like OpenTelemetry. So OT is kind of taken and it doesn't stand for off topic, but it stands for OpenTracing. That's why the abbreviation for OpenTelemetry is OTEL, and OT is normally OpenTracing. It was vendor neutral, but it's kind of dead now. It kind of paved the way for the larger OpenTelemetry movement, I want to say, and it was the starting point. It was just not enough, but it has like in terms of terminology and everything, it paved the way because you have the entire request and you have the parent call basically, and then you have the child calls, and then it might reach out to another service. What is also quite nice in this graphics, that's why I like to include it, is that it shows the kind of like how logs fit into this. So a trace is the entire request. What OpenTelemetry can capture. And if you have log messages, these are kind of like at these individual points, but they don't have this overall picture. You could include the tracing ID into logs, so then you could figure out this log message belongs together with these other log messages and was from one single request. So tracing and logging can work together to some degree, but logs alone cannot give you that overall picture that tracing can give you. However, if you don't want to do full-blown tracing because it might add more overhead or the backend storage might be expensive, you could use the tracing IDs just to figure out which requests in the log belong together, and then just inject those IDs into the log. So you can always say, okay, I see this log message, give me the context, what were the other log message for this specific request? So that tracing and logs are not really opponents, but they can work together. And that is also a big point of what OpenTelemetry is doing, is that it's saying like, well, we have these three different things, logs, metrics, and traces. They're generally better together. So let's bring them together. So that is a large degree of what OpenTelemetry is then giving you over OpenTracing, which was just like, okay, let's correlate the headers for traces. Which could then look something like this, but I'll skip over this because this is not super relevant anymore. The thing for OpenTracing that was kind of a downside was that it was only API and headers. There was no wire protocol, neither in-band nor out-band. So in-band is the propagation of the information between the services within your request. Out-band would be that your service at some point needs to send kind of like all the tracing information that it has collected to a central storage point so that you can reconstruct the requests. And neither are covered by OpenTracing. That's why at some point W3C Trace Context, that I can say it, came in to fix that, to make that passing along of the information more standardized. So they standardized the headers, how that can work and how that information can be propagated. But that again was just a standardization kind of like intermediary step by now, I want to say, because OpenTelemetry is kind of like what soaked all of this up. It's open source, it's a project of the Cloud Native Foundation, and it tries to combine traces, metrics, and logs, and this is also the order in which they tackled them. So traces are, I want to say, very mature by now and kind of like almost the way most projects will want to approach tracing. Metrics are early on, you can use them. Logs are very much on the experimental side. But the bigger picture is that in OpenTelemetry, you try to take traces, metrics, and logs, or just one of them, or any combination that you think is useful for your project. Have a standardized way how to collect the information, and then can export that to various OpenTelemetry backends. It does replace OpenTracing, like I've said. There was Open Sensors from Google, which has kind of like OpenTracing plus Open Sensors were almost joined together, extended, and that is what OpenTelemetry is today. And it tries to unify in your application how you extract all of this telemetry information from your application, and then you can expose it to various backends, and this is where vendors come in again. So within your application, you use an open standard that works for any system, and then you can, in the backend, decide who can store your data best, who has the best visualization, who allows me to drill into my data to search what I want to find. What is the tool that I want to use there? I don't want to compare it too much to SLF4j and then the logging interface and the logging backend, but it's kind of like you have a standardized interface that you're talking to, and on the backend you can then decide like which is the implementation that makes most sense for me and that I want to pick. And OpenTelemetry is vendor neutral, it's widely supported, and various players are very active in there to contribute and move it forward. But everybody has their own backend implementation of how to store the data, how to visualize it, how to query it. So on your application side is standardized, the backend then you need to make a choice. Like I said, the status is tracing has been stable for a while and has been going very strong. Metrics are stable from the API, and the SDK, I think, is in feature freeze mode right now. So the SDKs are also getting ready, and Java is one of the first ones to get into that. Logs are still in the draft state. And by the way, when I'm speaking about stable and everything, I'm mostly speaking about Java, and Java is very much at the forefront of how things are going. That doesn't mean that all the programming languages are at the same state. So for example, I think PHP is still very, very early on in the stage, even for tracing. And PHP is kind of special in that regard because I think it's pretty much the only language where you don't write the instrumentation in the same language. So the Java agent to instrument Java application is written in Java. PHP is not doing that because of their architecture. There you need to write it in C, so it's kind of like a heavier lift than the a smaller subset of people actually who can do that. But most of the services are actually very focused on, or most of the things are, Java is pushing very much to the forefront of what is possible today. So if you're in the Java ecosystem, then you will have a good time and be able to make this work pretty well. Now, how do you integrate OpenTelemetry, which kind of like is the open source standardized way that sits in your application? How do you implement it to the vendor-specific backend? And vendors can implement one of up to 3 ways or multiple ones of them. So the 3 ways could be, you have your OpenTelemetry agent for whatever language you're using. And then in the agent, you need to add, or you can have a vendor exporter. And that kind of like purple color here, from here on, everything is vendor specific. So the outband, like the whatever is being sent over the network, is already in the vendor specific protocol. It has its vendor specific thing that collects the information here, and then you can visualize it. This works. The main downside is that you need to support and keep up to date the exporter for every single agent that is out there. So these are just some of the agents. There are more. And if you want to go that route, the vendor needs to have that vendor exporter for every single programming language in, well, all of these languages. So this is kind of some work. It was, I want to say, popular as the first step. Nowadays, many have changed to a different approach. So you can use the agent. This is OpenTelemetry. Also, the networking protocol here is the OpenTelemetry protocol. And then you have the so-called OpenTelemetry collector, which is, I don't know, let's say it's like a proxy. And then you only need to have a vendor exporter once in this proxy here. And from here on, it's the protocol of the vendor. So basically, you only need to connect one thing to your product, and then you can work with that. It also helps you because you, in your application, you don't need to care which vendor is supporting which agent or anything like that. And everything here is vendor agnostic. If you want to switch out the vendor, you would only need to switch the exporter in the OpenTelemetry collector here, and you're done. So if you say you want to switch from vendor A to B, you change the configuration in the OpenTelemetry collector, you restart the OpenTelemetry collector, and that's all you need to do, basically. And your applications don't even know that anything changed. This is appealing. I think the main downside here is that you need to run this OpenTelemetry collector yourself, so you have another piece of software. On the other hand, it might also be nice. I know that some larger companies especially like this approach because they run at least one OpenTelemetry collector per availability zone in their data center. So they have most of the network traffic in here, and then they only have like a subset of the data going out of one availability zone, and they want to collect as much as they can within one availability zone of a cloud provider. Final approach could be that an observability vendor could also implement the OpenTelemetry protocol. So this time again, your agents would be configured to point to whatever endpoint that is, and that needs to speak the protocol, and then the vendor can pick up that information. And of course, you could also forward information from the OpenTelemetry collector. So this is also fine. This makes also sense. I think the main downside here is that if you want to switch out the OpenTelemetry vendor, you need to reconfigure all your agents. So you might still want to let your agents forward to the OpenTelemetry collector. And if that can then speak the protocol, OpenTelemetry can just forward the information in its own protocol, and the vendor can pick this up here. In case you're wondering which approach Elastic has chosen, so we have started with this because it was kind of simple, though we have switched to this approach by now. So by now, you can just throw whatever OpenTelemetry information you have, either directly from your agent or from a collector against our API, and then we can work with that. And I will show you that live in a minute, and we'll have about like 5 to 10 minutes for the demo for that left. Like I said, this is the approach that we support. So we have, for historic reasons, our own protocol as well, and support the OpenTelemetry protocol. So your agent or your collector here, this is the approach that I will be using in my demo, will forward information here. There's the so-called APM, or nowadays we call it fleet server, that takes that information, stores it, and then you can visualize it in any way that you want. Let's go to the demo. Or before we go to the demo, taking one quick step back for Java, how do we actually instrument our Java application? Java has the very nice approach that while you can do it manually in like the main method, there's also this concept of agents. Like normally you do -java agent when you run something, so you can just instrument the application at runtime with the so-called pre-main or agent main methods, which are kind of like alternative entry points into your applications. If you want to read more about that, there is a very good blog post by Raphael, the ByteBuddy creator, to explain that concept of how instrumentation works better. And if you have something that is well supported, like Spring Boot, you can just throw that Java agent at your running application and instrument it at runtime. You don't need to have any build or compile time dependencies, and you can just configure everything once you run it. So even if you say like, oh, I didn't care about this initially when I built the application, you can just add it on top at any later point if you want to. And it looks then something like this. So here I start my application, which is on this in this package here. And then I could say like, this is the Java agent, and then I just include the OpenTelemetry Java agent. At runtime, you might have some export parameters set, like this is the server where the information should be forwarded. Maybe you have an authentication token that needs to be included. You can also add some metadata to the service. So for example, if I want to say like this service should be called frontend, it's in version 1.0 and it's in the production environment, you can set these attributes, and then it will be shown like that in the application. And then you could filter down like, okay, show me the errors in version 1.0 and show me the errors in version 1.2. To compare like what changed over time. So with that metadata, you can then have a more fine-grained view of your services. The application that I'm using is very simple. I'm having a front-end service where it's like a shopping cart. And then I have an anti-fraud service that says like, well, your transaction looks good or it doesn't. Both are backed by a Postgres database. I have something that I call like an injector or a load generator. So we actually see something and then we forward it to the OpenTelemetry collector, and then it will forward that. And I actually need to update that graphic. So this part here is actually speaking the OpenTelemetry protocol now, because here we support, or Elastic supports, the OpenTelemetry protocol here already now. The one thing that you still need to keep in mind is that sometimes you need to manually instrument. So the kind of like the tooling or framework stuff, like what is the database query? How long does a database query take? What is a request? What is the response code? These things work very well for especially Spring Boot and widely used frameworks. But sometimes you have more like business logic things, like this is the price of this thing. This is the payment provider. If you want to add anything like that, you will need to add that manually. So manual instrumentation is still very much a thing. However, like a bit like SLF4J, it's vendor agnostic. So you can just annotate everything the way you want, and you don't need to care about or fear any vendor lock-in about it. Okay, so let's see what we have. So I have a very simple service here. And let's say I want to buy 4 TVs, and I add that to the cart. and then I click checkout. And then when I click on pay, it will actually check if this is allowed or not. And as you can see, there is some time. At first it says like, no, it's not allowed. And then once it has successfully checked it, it will actually accept my transactions. And depending on how lucky or unlucky I am, I think the more expensive it is, the more likely it is that it will actually reject my transaction. But it looks like we are lucky today and all our transactions work. Let me quickly start the load generator. No, this is not what I wanted. Let me start my load generator. And this will generate load. So you can see this is what the payment providers, if it's a large, small, or a medium order, etc. And like any dash means it succeeded, and any X means it failed. So we're creating some good load on that system. So now how have I instrumented my application? So I'm using the OpenTelemetry collector. The only place where I kind of like had anything Elastic specific is in this exporter, where I say, okay, the endpoint is of the OpenTelemetry exporter is it goes to Elastic. This is the endpoint, this entire thing. And then I have an authentication token that I've also added here. And this is really all I need to do in my application. So for example, here to run the front-end application, where is it? If I don't see it here, let me open it here. So what we're doing here, the only instrumentation that we're doing here is I'm taking my front-end application or whatever other application you're using. I have a variable that pulls the current OpenTelemetry agent and then just adds that and auto-instruments it. And as I've shown you here, this is like some meta information that I'm adding to my service. This is everything that I'm doing to my application here. I do have a little bit of manual instrumentation added here. So here, when I create an order, I add something like the customer ID, the price, the payment, etc., so that I can actually filter out like, okay, which customers were affected by a problem, what shipment methods might be affected by any errors that I run into, etc. So that instrumentation here gives me a better overview of the information that I see in my system afterwards. So let's take a quick look. So OpenTelemetry in my application, the OpenTelemetry collector forwards it to this instance here, which will then store it in these two Elasticsearch instances, and then I have one Kibana instance to visualize it. This part here behind the OpenTelemetry collector, that is vendor specific, and then you could just pick whatever vendor you like and do you think is like efficient, has good visualizations, allows you to do various things. So here, this is the part that you can pick, and you could just exchange whatever window you want to have. So here, I copy the endpoint for us. Whatever other system you have, you would just need to replace in that configuration here the endpoint and potentially the token. And that's all there is to switch out the backend vendor. And then what you get out of this, and let me refresh that. And you can see the latency of my services. And for some reason, the anti-fraud is slow. So we might want to look into that, why this is the slowest service. You can also see the throughput. And as I've just started the load generator, there's no surprise that here the load is starting to increase. We can also see the number of failed transactions. So this is a bit higher on this service. So maybe we take a look at front end here. And then you can see these are the API endpoints that you can hit on the service. This is all automatically extracted by OpenTelemetry. You can see the latency and the throughput and the error rate. And then you would might want to see, okay, here, these are the ones that are rejected by the fraud service. And they are just shown as failures here. You can also see the individual transactions and could say like, okay, I'm only interested in the orders. Let's look at the orders. You can see what is the latency of these. Once I started the load generator, the latency seems to have gone down slightly again. And what is the throughput? What can my little service on my laptop here run? And you can see the failures as well. You see like the latency histogram. You could, for example, dive into just these. And then you see for one specific request here, for example, you see the entire collection of like these were the requests and systems that were hit. So you can see front-end service, anti-fraud service, and then I have a checkout service that I haven't really described, but it's basically doing the checkout process for you. So request comes in, you can see how much time each step takes. You can see what database queries you're running, for example, and how long they take. We're using Postgres here. And you can basically see where are you spending your time, and you can see most of my time I'm actually wasting in the fraud service. So this is probably what I should be checking out next to figure out how to make this faster. And if we dive into that, we would see that there is a sleep in there to make that a bit slower, and it's also random to make it a bit more uneven, so that some of the requests are fast and some are slow, as you probably might have it in lots of your services. Some things that are also nice is you can look at the service map, where you can basically see how your application belongs together. So you buy something, it goes through the anti-fraud service, both are backed by Postgres, and once that is okay, it hands it over to a checkout service that will actually hand that over to a shipper. And this here is the OpenTelemetry collector that is not fully correctly annotated here, but well, it's another service that we're running here. You can also look at the dependencies. It would know like Redis, Postgres, whatever other services you're running here, and how this service is doing in latency, in throughput. So to help you pinpoint what is creating load, what is slow, where do you need to start looking to actually find a problem. Okay, since we are running a bit low on time, let's wrap this up. You can still use the APM or tracing tools of vendors, which are vendor specific, and they might for now at least have some more tooling than OpenTelemetry. But OpenTelemetry is catching up fast, and it's kind of like supported by many people, and many people are adding features. So I'm not sure how long this will actually be true. In the past, you could use OpenTracing, but that's dead. You could use Jaeger more, which was almost like a standard, but I think that's also the thing of the past. What you probably want now is OpenTelemetry nowadays, definitely for tracing where it's stable. Metrics are coming along and will be the new thing soon. So if you're using Prometheus, you might want to keep doing that. If you're not using Prometheus yet, maybe OpenTelemetry metrics are a good thing. Logs are still much less mature and are more in the up and coming phase for now. So to wrap up, I hope I made clear why you want tracing and logs and metrics, and how you can see more in your application. Why everybody loves OpenTelemetry, because suddenly you don't have anything vendor specific in your apps anymore, and you could switch out the vendor without any bigger problems. And it's available today, and you can just use it with various providers, and you can just pick whatever makes sense on the backend for you. And that's it. Thanks a lot.